بسم الله الرحمن الرحيم. هنبدأ النهاردة Universal Gravitational Loop. First question. If the distance between the center of two bodies is double and their masses are kept unchanged, the attraction force between them will be the attraction force equal Gmm divided by r power of 2. Since the distance between them is doubled, then the force equal 1 over 2 power of 2, then the force equal 1 over 4. This means that the force decreases quarter its value. If the distance between the center of two masses decreases to its half, and the force of attraction between them will be, since the force equal Gmm divided by the distance power of 2, and the distance decreases to half, then the force increases 4 times. Two similar poles, each of them of mass m and radius r, are placed in contact to each other. Then the gravitational attraction force between them is given by the relation. These are the two poles contact with each other, each of mass m and radius r, then the total distance equal 2r. Then the force is given by the relation. Two poles of masses 8 kg and 20 kg. The distance between them, their centers, is 0.2. If the universal gravitational constant is g, so the attraction force between them is, since the force equal Gmm divided by the distance power of 2, then by substituting the number in the relation, then the force equal 4000 G. The distance between the center of two identical poles is 1 meter. The force of attraction between them is 1 Newton. Then the mass of each of them is. This is the relation of the force. By substituting the number in the relation, then m power of 2, then by square root, then the mass is the ratio between the gravitational constant on the Earth's surface to that on the Moon's surface is. It is the same. The universal gravitational constant is the same for each of them. Then the ratio between them equal 1. Two bodies of masses m1 and m2, and the distance between them is r. If the masses of the first body is doubled and the distance between them also is doubled, then the force of attraction between them. This is the relation of the gravitational force. One of them is doubled and the distance is doubled, then 2 divided by 2 power of 2 equal half. Then the force decreases to half. In the opposite figure, the relation between, the relation that represents the relation between the force and the time is, at the first, the relation between the force and the distance is inversely proportional. And the relation between the distance and the time is directly proportional. Then the distance between force and time is inversely also. So, which one is inversely proportional to time? F proportional inversely to time. Two asteroids, one of them of mass and the other of this mass, and the distance between is given by, then the gravitational force on the large asteroid is F equal Gmm divided by the distance power of 2, then by substituting the number in the relation, then the force A satellite orbits the Earth at a distance of 100 kilometers. The mass of the satellite is 100 kilogram. while the mass of the Earth approximately equals 6 times 10 to the power 24 kilogram. And the radius of the Earth is approximately 6.4 times 10 to the power 6 meter. So the approximate gravitational force acts is, this is the relation. By substituting the number in the relation and converting from kilometer to meter times 10 power of 3, then the force equal approximately 9.5 times 10 power of 2 Newton. Two satellites of equal masses orbit a planet. Satellite B orbits at twice the satellite radius of satellite A. Which of the following statements is true? At the first, this is the satellites that orbit the planet. One at a radius r and the other at a radius 2r, twice the distance. Then, this is the force of the first satellite and this is the force act on the second satellite. Then, the force of the second satellite equal quarter the force of the first one. This means that the force of the first satellite equal 4 times the force of the second one. A 70 kilogram astronaut floats at a distance 10 meters from a 50,000 kilogram spacecraft. What is the force of attraction between the astronaut and the spacecraft? At the first, this is the relation of the gravitational force. By substituting the number direct to the relation, then the force equal 2.4 times 10 power negative 6. Two masses M1 and M2 are separated by distance d. What changes in the variables will result in no change in the gravitational force between them. The gravitational force will be constant, equal to 1. Which one will be constant? Let's try the first answer. F equal, if the mass is doubled and the d is doubled, then the force equal half. The second choice, if the mass is tripled and the d is quadruple, this means that F equals 3 divided by 4 power of 2 equal 3 over 16. If both M1 and M2 are tripled and the d is tripled, then 3 times 3 divided 3 power of 2 equal 1 over 1, that is equal to 1. This is correct answer. Let's try the last one. If M is quadruple and d is doubled, this means that F equal 4 divided 2 power of 2, that is equal 1 over 1, that is equal also 1. Then we have two choices are correct. Letter C and letter D. A block of mass 30 kilogram is hanging still from a string. If you place another block with a mass of 10 kilogram at a distance 2 meters away from the first one, so the gravitational attraction between them is. Let's try it. This is the correct answer. Mars orbits the Sun at a distance of 2.3 times 10 to the power 11 meter. The mass of the Sun is 2 times 10 to the power 30 kilogram, and the mass of Mars is 6.4 times 10 to the power 23 kilogram. Approximately, what is the gravitational force that the Sun exerts the Mars? By substituting the number in the relation direct, then the force equal 1.6 times 10 to the power 21. The moon had the mass of 7.4 times 10 power 22 kilogram and the radius is 1.7 times 10 power 6 meter. The force of gravity by 70-kilogram astronaut standing on the lunar surface is. Also by substituting the number direct to the relation, approximately 120 Newton. The planet Jupiter orbits the Sun at a near constant speed. What if the following statement are true? This is the solar system, and the force act on Jupiter is towards the center, also the acceleration towards the center. Four planets orbit the same star. The relative masses and the distance are given in the following table. So, which planet has the highest gravitational attraction to the star? Let's say it's a planet. Force equal gmm divided by the distance power of 2. This is the force act of the first planet. Let's try the second planet. F equal 100. The third planet, and this is the fourth planet. The highest gravitational force is planet B. The acceleration due to the Earth's gravity is G equal gm divided by r power of 2. The gravitational intensity or the gravitational gravity is inversely proportional to the distance. Then it is changing according to the height from the Earth only. Second question, given the following givens, then the gravitational field intensity is G equal gm divided by r power of 2, substituting the following numbers direct in the relation and try to convert from kilometer to meter times 10 power of 3 times 10 power of 3. This is the correct answer. On the scale of building, the gravitational field intensity is constant or uniform. Which of the following affect the strength of the gravitational field on the surface of the planet? The relation G equal gm divided by r power of 2. Then G is directly proportional to the mass of the planet and inversely proportional to the distance or the radius of the planet. Then the correct answer is the mass and the radius. Assign the acceleration of the moon simple by am, and the mass of the moon is m, like that. Then, what is the gravitational field strength at the satellite's orbit? Since the moon and the satellite are in the same orbit, then they will have the same acceleration. If the acceleration due to gravity of the Earth at the orbit of satellite that orbit the Earth is 2.5, then the distance between the satellite and the Earth is. Let's make the ratio between the gravitational of the Earth to the gravitational of satellite that is inversely proportional to the radius square divided by the radius of Earth square. Then the relation equal the radius of satellite r plus h power of 2 divided by the radius of the Earth. Substituting the numbers, then 4r power of 2 equal r plus h all power of 2. Let's make a square root for the two sides. Then 2r equal r plus h, then h equal r. if r is the radius of Earth, so the height at which the weight of a body becomes 1 over 4 its weight on the surface of Earth is. Since the weight equal force the weight on the Earth, then weight equal mg equal quarter mg of the Earth, then the gravity or the intensity at this point equal quarter the gravity on the Earth. By substituting the relation gmm over r plus h all power of 2, then by taking the square root of the two sides, then r plus h equal to r, then h also equal r. At a place the value of g is less 1% than the value on the Earth's surface. This place is, let's try. Since at this place x, for example, g at the place x equal 99%, it is less than the gravity on the Earth by 1%, then it's equal 99%. Since the gravity of the Earth divided by the gravity at this point x equal rx power of 2 divided by r the gravity of the Earth power of 2, then by substituting the number, cancel GE with GE, the gravity of Earth with the gravity of Earth, cross multiplication, and taking the square root of the two sides, divided 6400 divided by square root 0.99, then h approximately equal 32 kilometer. An object has a mass 50 kilogram and a weight of 500 Newton. If it moves at a height equal 3 times the Earth's radius, what is the object's new weight? Since the height equals 3 the radius of the Earth, from the ratio, then the gravity of the Earth equal 10 divided by the gravity at this point x equal r plus h power of 2 divided by r. Then substituting instead of h 3r, then 10 divided by g at this point x equal 4r power of 2 divided by r power of 2, then 16g equal 10, then g at x equal 0.625, then the weight equal m times g, m is 50 times this gravity, then the weight is 31.25. Two asteroids in the space are close enough to each other, each has a mass of, if they are 100,000 meters apart, the gravitational acceleration is, since the gravitational acceleration equal gm divided by r power of 2, substituting the number direct to the relation, then the gravitational acceleration is two asteroids, one of mass 7.12 times 10 to the power 18 and the other 5.33 times 10 to the power 8 kilogram. The distance between them is 10 times 10 to the power of 10 meter. Then the acceleration of the small asteroid is. This is the relation, and substituting the number direct to the relation, then the gravitational acceleration is when climbing from the sea level to the top of a mountain Everest, a hiker changed the elevation by 8,848 meters. By what percentage will the gravitational field of the Earth change or decrease during this climb? At the first, this is the ratio that is equal the gravitational at this point x or at this height x divided by the gravity of the Earth equal the radius of the Earth divided by r plus h all power of 2. by substituting the number to the relation, then the ratio between the gravity at this point or at this height x to the gravity to the earth is 0.99 times 100. The percentage is 99.7%. Then it decreases 0.3%. The orbital velocity that required to keep the satellite rotating around the Earth depends on, this is the relation, then it depends on the mass and the radius. G is constant. The orbital velocity of satellite is inversely proportional to square root the orbital radius. Two satellites A and B rotate around the Earth if the orbit radius of the satellite A equal 4 times the orbit of satellite B. So the ratio between the velocities is, since the radius of A equal 4 times the radius of B, then the relation between them is inversely. Then by substituting instead of RA for RB, then V squared divided V squared equal 1 over 4. Then V of A divided V of B equal half. A satellite rotates at a height 12,000 km from the planet of mass if the radius of the planet is given and the gravitational constant is, so the orbital velocity, this is the relation, substituting directly to the relation and convert from kilometer to meter times 10 power of 3. This is the correct answer. Two satellites have the same orbital radius. One rotates around the Earth and the other rotates around Mars. If the mass of Earth is 9 times of Mars, then the ratio between the linear speed of the satellite rotating around the Earth to that around the Mars. Since the mass of Earth equals 9 times the mass of Mars, this is the relation between the velocity and the mass. Velocity squared is directly proportional to the mass. Then V square of Earth divided V square of Mars equal 9 over 1. Then V divided by V equal 3 over 1. A satellite orbits the Earth at orbital velocity. This is the value of the orbital velocity. Then the distance between the satellite and the surface of the Earth is, since in V equal root gm over r, that is equal in the question half root gm over r capital, then by making power of 2 for the two sides, then cancel gm with gm, then r small equal 4r capital. This means that r plus h equal 4r, then h equals 3r. Two satellites S1 and S2 orbit the Earth at different heights from the Earth. If the ratio between their periodic time T1 over T2 equal 8 over 1, then the ratio between their orbital velocity. At the first, the relation between the periodic time and the radius is T power 2 proportional to cubic radius. Then the cubic radius 1 to cubic radius 2 will equal 64 divided by 1. Then R1 over R2 equal 4 over 1. Since the relation between the velocity and R is inversely proportional, V square 1 over V square 2 equal R2 over R1, then it is equal to 1 over 4 by making square root for the two sides, then V1 over V2 equal half. A satellite orbits the Earth at 200 km. If the mass is and the radius is, this is the relation, and substituting the number directly to the relation and converting 200 km to meter times 10 power of 3. Phobos, a moon of the planet Mars, whose orbital radius is 9,380 kilometers. Its orbital period is 0.319 days, that is equal to 0.77 times 10 power 4 second. Then the mass of Mars based on this data is. This is the relation. Making power of 2 for the two sides. Then the mass equal 4 pi power of 2 cubic r divided g t power of 2. The orbital radius of the two satellites rotating around a planet is. And given that the periodic time of the second satellite is 8 times 10 to the power 7, then the periodic time of the first. The relation between periodic time and the radius, substituting the number in this relation, then periodic time T1 is, by making a square root for the number, then the periodic time is 2.26 times 10 to the power 8, approximately 2.3 times 10 to the power 8 second. Two satellites at the same distance from the Earth. One of them has a mass m and the other has a mass 2m. Since they are orbiting the Earth at the same distance, then they have the same acceleration.